Hello, Miss Bell's Algebra 2 class. This is a quiz review. This is the 16th, and I don't think you guys are going to go over this until Monday on the 19th, so I want to do at least every other one with you. So solve each equation by factoring. You must show the factored form. So this is already ready for you. This is nice and easy. Just set 3a minus 5 set to 0 and a plus 8 set to 0, and you should get where a equals 5/3 and a equals -8. For number 3, we are going to, I actually did this by taking the square roots. At first I didn't really realize that what we were supposed to do. I added 3 to both sides, and then I divided both sides by 3, and I ended up with n squared equals 1. I took the square root of 2 and the square root of 1, and I get n equals plus or minus 1. You get the same thing when you do actually factor it out. I factored out a 3, and it could be plus 1 or minus 1, so n could equal the -1 or the +1. For number 5, if I subtract this 2 from both sides, that'll set it to 0. That's what I need to do first. And then I factor this out, and I figure I look at what I can multiply to get -24 and add together to get 2. And that would be 4 and 6, and that's a -6 because I have -2. So the 6 has to be the negative. So then I just set p plus 4 set to 0, so that would equal p equals -4, and p minus 6 equals 0. And I just solve for p, and so that would be p equals +6. Here I just combined my like terms, got it all on one side of the equation, factored it out. What I can multiply together to get -18 and add together to get a +3 is going to be 6 and 3. And so when I take n plus 3, set it to 0, that's going to give me n equals -6. And when I take n minus 3, set it to 0, I just solve for n. And so I add 3 to both sides of the equation. I get n equals 3. So for this one, the perfect squares in our notes from earlier in the week, we had these, perfect squares list that she had all the way to 225. So it's, the perfect squares of, 1 through 15. So you just look at this number, you just got to figure out, like, what two things can I multiply together to get to 294 if there's a perfect square in there. And I came across 49, and it was 49 times 6. 49 times 6. The square root of 49 then is 7, so that comes out. And this is going to be your square root of 6. So that would be, plus or minus that value. This one, I'll get you started on this. The 128 is 64 times 2. That 64 is on my list. So I just figured, well, it's going to be 64 times 2. So, bring out the 8, and you're going to have the square root of 2 left. Okay, so I might as well do that one for you. So it's plus or minus 8 square root of 2. That's how you do those. Those are pretty easy. Solve each equation by taking square roots, and this is what we were doing with that one puzzle this past week. I added 5 to both sides, or I'm sorry, I subtracted 5 from both sides, and then I divided both sides by a -9, and then I took the square root of both sides, and the square root of 5 is plus or minus 5. This one, I subtracted 6 from both sides. That's how my 54 became 48, and that's how my 3n squared became alone on this side of the equation. Then I'm dividing both sides by 48. That gave me my n squared alone, and it gave me 16. 48 divided by 3 is 16. I got to take the square root of both of these, and the square root of 16 is 4, so it's going to be a plus or minus 4 there. And then solve each equation by graphing, and you could use your graphing calculator. I would show you, but mine has died from doing these. I guess the batteries went out. Or you could go on Desmos. When you go on Desmos, What's nice is if you plug this in just the way it is, you don't even have to put the equals 0. Plug this in, you could see where it crosses the x-axis, at 40 and negative 7.6 repeating 0. You could follow the instructions on your notes from this past week on your graphing calculator for number 17 also, or you could use Desmos and plug this in. Now you have to put it in standard form, so you have to, get this 8, you have to subtract 8 from both sides, and it ends up being this minus 7 here. And put this in, and you will be able to easily see on Desmos where it crosses the x-axis, or you could use it, like I said, in your graphing calculator. Hopefully this helps, and good luck with the rest.